I think this is another repeat slide. I think you've probably seen this before, but that kind of, I call it webbing this semester. This is my first semester to use that term. The things that keeps the repeating units together, the intermolecular bonds. I call them intermolecular bonds. This is calling them intermolecular forces. Okay, but it can connect molecules to molecules. We'll talk more about ions to molecules and ions to ions. I want to spend just a little bit more time talking about this idea of matter changing its phase. So here you see solid, liquid, and gas. Okay. Now to go from what I say left to right, to go from a solid to a liquid to a gas, actually we are going to be breaking bonds. We're going to be breaking those intermolecular bonds. And as we go from right back to left again, from a gas to a liquid to a solid, we're going to be forming those bonds, right? Okay. And you guys would probably tell me as I go from left to right, I think I wrote this up on a recent video, as I go from left to right, solid to liquid, liquid to gas, I need to add heat. And heat actually is a form of energy. And maybe not so much as intuitive, but this is the way it goes. I'll change my color to purple. As we go from gas to a liquid, as we go from a gas to a liquid and a liquid to a solid, of course we are forming bonds, and in that case, heat is released. So heat is released. One of the things I have talked about, released, I can't spell released, R-E-L-E-A-S-E-D, okay. In meteorology, one of the things that is awesome is this idea that clouds, within a cloud, water vapor is going from a gas to a liquid. That's what makes our clouds. And during that process, heat is released. Actually, when that's happening, that condensation, the cloud's getting warmer, and that's a player in kind of why clouds do what they do. Anytime heat is released, we call that exothermic, and think of exo as in exit. Heat is exiting, okay, exothermic. Something where, so exothermic would be this guy up here, okay, that's exothermic. Anything that requires heat, we call that endothermic, endo, okay? So heat in. And of course that would be our left to right thing. I'll put 2 asterisks there. Oof, I don't know if I can follow my own. Okay, very good. So, now those were intermolecular bonds, but actually even chemical bonds do the same thing. So I like this little, almost could put this to a rap song. That's on my list of things to do, is to make songs out of science things. But so it takes energy to break bonds. Okay, that was kind of our left to right. And actually when bonds are formed, that was our right back to left again, energy is released. Very good. So these are terms you're probably already familiar with. So for instance, if I would ask, what do we call it when a solid goes to liquid? You would say that is melting, and you'd be right. What do we call when liquid goes to a gas? We call that evaporation or vaporization, same thing. Now that was the left to right. Now right to left, what do we call when a liquid goes to a solid? Well, we call that freezing. You're right. And last but not least on this slide anyway, what do we call when a gas goes to a liquid, like in clouds? We call that condensation. All right. So here is, see if this video plays. It should. I've been having pretty good luck here.
Molecules of a liquid have a range of kinetic energies. Some have enough energy to overcome intermolecular forces. If these high-energy molecules are at the surface of the liquid, they can escape into the gas phase. This is an endothermic process.
Well, nice little video there. I hope you kind of caught that as those, that's not going to work. As those particles escaped their liquid state, notice that those particles stayed intact. There was no new substances were formed. Also, I think this points out another thing I think is so cool. They call it equilibrium, but all liquids depending upon their volatility, are going a little bit into their gas phase. So I think that's so neat. Let's see, what do we have next? Oh, so this is just a figure from your textbook, again showing you the Mickey Mouse molecules are the H2O, the oxygens are red and the two hydrogens. And you see water in its liquid state and in its gaseous state. Okay, so this is trying to kind of prove to us that this is a physical change as it goes from a liquid to a gas. No new substances are formed. That looks serious. No. I'll be back.